Here's an explanation on exercise P5, number 33, even and odd functions. First, let's see what an even and an odd function is. Definition: a function is even if for all x in the domain, so if for whatever x the function can take, the function value at the point is the same as the function value of negative of this point. F of x equal to f of minus x. A function is odd if for all x in the domain, the function value of x is equal minus the function value of minus x. F of x equals minus f of minus x. That means the difference between the definition of an odd and an even function lies in one extra minus for the odd function. This has the geometric interpretation. These two equations define some symmetries of the function. Namely, an even function is a reflection on the y-axis. Look at, for example, the red x and then the minus red x. The function value should both be the same, so the y value should be the same. And that's true for all other values as well. So for the x and the minus x, that is white, and the a bit difficult to see, but green x and green minus x, in each case, the y value should be the same for the x and the minus x. That is saying the function is reflected on the y-axis. So these are even functions. An odd function has this extra minus. So for the red x, if this is, I don't know, let's say 3, then for the minus red x, the function value should be minus 3. It's just like for the even function, but instead of going up, we should go down on the other side of the y-axis. And that is nothing else than a point symmetry around the origin, around 0. Or you could also imagine, which is equivalent, that you rotate everything by 180 degrees around the origin, and then the function should be the function itself again. So these are even and odd functions. Now let's see what the exercise wants us to check. We know that we have two functions, f is even and g is odd. And we're supposed to figure out whether a function that is formed by adding these two is also even or also odd. That's the first part. So we use everything we know and write it down. So first, f even means f of x equal f of minus x. G odd means g of x equals minus g of minus x. What does it mean to add two functions? That is, the function f plus g is defined as, this is why I write these two little dots in front of the equation sign. That means whatever is written on the side where the two dots are is just a naming for what's written on the other side. Namely, f of x plus g of x. That is, the addition of two functions is really exactly what you think it would be. We're adding the function values at each x. Okay, now I want to know whether f plus g in general is an even function or an odd function or neither, if I know that f is even and g is odd. So I'm using that. I start with f plus g of minus x because I want to know whether f plus g of minus x equals f plus g of x. If that was the case, then I know that the addition is even. If f plus g of minus x happens to be minus f plus g of x, then I know that the function f plus g is odd. So let's see. F plus g from minus x is f of minus x plus g of minus x. This is just what the addition of two functions is. And now I'm using f is even, so I replace f of minus x by f of x, and I know that g is odd. And that means g of minus x is the same as minus g of x. That's the second part. Well, and that is neither f of x plus g of x, so it's not even, nor is it minus f of x minus g of x, so it's also not odd. Seeing this graphically, there are the two examples of an even and an odd function on the bottom on the right, and if I just add up their function values at each point, it more or less makes this green function that is drawn on the top. And you see this one is neither symmetric to the y-axis, nor can I rotate it by 180 degrees around the origin, and it is itself. So the addition of this example of an even and an odd function is neither even nor odd. that would also be a proof for saying that f plus g is not an even or an odd function in general, because you just gave an example where it's not the case. Okay, that's it. Next part. Second part of the exercise is to figure out whether f times g, so this is really a times, this is not a circle, whether f times g is an even or an odd function, knowing that f is even and g and odd. Same story again. F times g, how is that defined? That is nothing else than multiplying pointwise, so f of x times g of x. And now I want to figure out whether f times g is fulfilling the equation for an even function or an odd function, so I start calculating with minus x. First step, I resolve the definition of what does it mean, f times g. That is f of minus x times g of minus x, and now I'm using again that f is an even function and replace f of minus x by f of x, and that g is an odd function, so I replace g of minus x by minus g of x. Now I take the minus out, because then I see that this is the same as minus f of x times g of x. And going backwards, using the definition again that this is the same as f times g function, I have minus f times g of x. Hey, that means we have a whole sequence of equations which shows us that f times g of minus x equals minus f times g of x. And that is exactly the equation that we want for an odd function. So we have shown that f times g is an odd function given that f is even and g is odd. What is a picture for that? That you see on the right. Taking the white function that is even and the red function that is odd and multiplying them, you see that the f value is of course always the same for x and minus x, and the g value is also the same but with opposite sign. So the product will be the same for x and minus x but with opposite sign. And that is exactly the definition of an odd function. If you rotate the green graph around the origin by 180 degrees, you see that it maps onto itself. Now there are a few more combination of f and g to check, and you always do it the same way. You write down what does the combination mean, and then you just compute what the function value is of the combination for minus x using that f is even and g is odd, and see whether or not the whole thing is even or odd.